This is Programme 1 of VideoTel series on practical marine electrical knowledge. The series is made up of 7 programmes. Programme 1 introduces a typical 440-volt AC marine electrical system, first aid rescue procedures and test instruments. It also discusses preventive maintenance. There are many system variations around, so it's most important that you become familiar with the components of the main switchboard immediately you join a ship. Pay particular attention to the layout of the emergency switchboard. This study will pay dividends during a blackout or when troubleshooting the cause of a major breakdown. Now we must emphasize electrical safety. The golden rule is, before any work is done on an electrical installation, first, isolate the circuit by removing the supply fuses or locking the circuit breaker in the open position so that the circuit cannot be energized accidentally. Then, post a warning sign to alert others that the circuit is being worked on. Then, prove the circuit dead with a voltmeter or an approved line tester. A switchboard can never be considered dead unless all alternators connected to it are stopped, locked off, and all other supplies are disconnected. These points can never be emphasized strongly enough. The electrical systems of all ships have to meet international safety standards in accordance with the International Convention Safety of Life at Sea 1974 and its amendments, and by the various codes published by the International Maritime Organization relating to all types of ships. Your ship is issued with a safety certificate in accordance with the appropriate convention. Practical guidance on electrical installation and maintenance is given in the rules and standards issued by the International Electrotechnical Commission. These are essential guidelines and rules which apply to all practical work on any electrical system on board ship. We begin with drawings and graphic symbols, as they're going to be our constant guides here and for you on board ship. On this drawing, you'll see a typical marine electrical system in its basic form. On a line drawing, the same system may look like this. We proceed by identifying the main components used and recognized internationally. So here they are. AC generators, or alternators as they're sometimes called, switchboards, buzz bars, circuit breakers, switches, fuses, transformers, motors, instruments such as voltmeter, ammeter, frequency indicator, wattmeter, power factor meter, ohm meter, synchroscope, and other loads. Under normal conditions, generated power on board ship is supplied by one or more main alternators and one or more auxiliary or standby alternators, depending on the power needs of a vessel. These alternators may be driven by steam turbines or diesel engines, although at least one of these should be driven by diesel power in any scheme. Should the normal power supply fail for any reason, an emergency diesel alternator is started up automatically or manually to provide power and lighting for all essential services on board ship. When a vessel is in dry dock, mains power may be supplied from shore. Provision for connecting shore power to the ship's system is given either at the main switchboard or at the emergency switchboard via a circuit breaker. In some cases, a separate shore supply connection box is used, where the supply from shore can be connected near the deck area. A permanent connection will take the supply from the connection box to the appropriate switchboard. The shore connection box is normally fitted with a voltmeter and a phase sequence indicator. In addition to this, a minimum level of lighting, fire and general alarms and communication systems must be supplied by a battery supply during an emergency, when the main supply is interrupted for any reason. In normal conditions, this supply is provided by a separate transformer rectifier system, and the batteries are on charge from a battery charger. Alternators are described in greater detail in Programme 3, and a more thorough description will be found in the book forming part of this series. And now, the distribution system. The heart of a ship's electrical distribution system is the main switchboard. The generated power is connected to it by the alternator circuit breakers, which connect power to the bus bars. Each alternator has a panel on the switchboard, and the alternators can be connected to the bus bars separately or in parallel. A separate synchronizing panel is located between the alternator panels, which has controls for auto-synchronizing or for manual synchronizing. These may be either a synchroscope or synchronizing lamps, or both. In addition, the panel has voltmeters and frequency indicators. Changeover switches determine whether the meters show the incoming data or the output of the unit supplying power to the bus bars. All these instruments are usually duplicated on the main control console for remote operation. A detailed description of manual synchronizing is given in Programme 3. The main switchboard will also contain the reverse power relays, protecting each alternator while running in parallel. Also, a preferential trip system is usually provided for tripping non-essential loads, in case the demand for power is greater than the connected alternator or alternators can safely provide. Several panels on the main switchboard will contain group starters. One of the feeder circuits supplies a bank of transformers, which reduces the voltage level to 220 volts, or in some cases, 110 volts for lighting and other consumer units. Another circuit provides typically 24-volt DC supply through a transformer rectifier system. This supply provides emergency power for emergency lighting, the not under command signal lights, certain navigation aids, and the communication and alarm systems on board ship, in parallel with the emergency batteries. On a separate feeder circuit, a battery charger keeps the emergency batteries on charge during normal conditions. The emergency switchboard is smaller than the main switchboard, and it is normally supplied from the main board through a buzz-tie circuit breaker. When the mains power fails, the emergency board is supplied separately by its own alternator. A particularly large example is shown here. The emergency alternator's prime mover is designed to start up automatically when its control system senses a large and sustained drop in the voltage or frequency of the main supply. The emergency switchboard will supply the emergency firefighting pumps and all other essential services. Also, it provides an alternative power source for a steering gear motor and navigation aids, as well as about 30% of the ship's lighting. From the switchboards, power is distributed throughout the vessel via section boards and distribution panels or fuse boards to every load or consumer unit which form part of the ship's electrical scheme. Now, a most important aspect of working with electricity: safety. Electricity is dangerous. Fatal shocks have been caused by voltages as low as 50 volts. it is most important that everyone becomes familiar with all safety regulations and procedures, as well as the essential rescue methods relating to electric shock. First, switch off the supply if possible. Remove the victim from contact with the supply. The victim must be made to lie comfortably and the pupils of the eyes checked. If they are dilated, this can mean that the heart may have stopped. External cardiac massage must be administered and the lungs inflated with oxygen in a rhythmic pattern until the victim regains consciousness and is able to control his own breathing. This rescue procedure is very important to remember. So, again, if you see anyone and suspect that they may be in trouble, for instance, not responding to a sharp call, switch off power if you can and remove the victim from the source of shock. The rescuer should be isolated electrically from the victim, or else he will get a shock too. Make him lie down. Check the pupils of the eyes. Ensure that the air passage is unblocked. Then start heart massage and the kiss of life. If the pupils are dilated, repeat the heart massage rapidly, 6 times for each inflation of the lungs. When the heart is restarted, the rate should be about 1 heart massage per second. When the victim regains consciousness, turn him on his side in case vomiting occurs, make him comfortable, and seek further medical help. So, to sum up, isolate the supply if possible, safely remove the victim from the source of shock, check the pupils of the eyes, clear the respiratory passage, apply fast heart massage to start with to restart the heart, and finally rhythmic massage and the kiss of life until the victim regains consciousness. Then turn him on his side and seek further medical help. Now let's look at some test instruments. The use of test instruments is a major element of electrical fault finding. They must be tested prior to their use to ensure complete reliability. For this purpose, a known supply of electricity is available at the electrician's test panel. Most test panels also provide testing for lamps and fuses. The most frequently used test meters are multimeters, insulation resistance testers, and line testers. A multimeter can be analog or digital type, and we'll describe their setup procedure here. First, an analog meter. For easy reference, the setup procedures are listed on the back of the meter or in the user manual provided by the manufacturer. Basically, the 2 dials work in combination when setting the meter up for any of its functions. Here, the meter is being set to read AC current by pointing one dial to the AC system and the other dial to the values range, in this case up to 1 amp. Voltage is set by the same dial. Here it is set to 600 volts full scale. For testing a DC supply, the dials change function. First, set the DC system, and with the other dial, select the range, as before. The meter can be set to measure the resistance value of a conductor by setting the ohmic system with one dial and with the other dial selecting one of a number of ranges of resistance according to need. Here also the two dials work in combination. For each range of resistance values, the pointer must be set to 0, while the probes of the meter are held together. Then, if a known value is checked, select the right range and conduct the test. The resistance scale of a multimeter can also be used to pinpoint an open circuit fault in a small component. Here, a variable resistor is attached to the probes of the meter. There is a break in the resistor coil. When the sweep arm is moved along the resistor coil, where the fault occurs, the meter will show a reading. Ensure that the meter is switched off after use. A digital multimeter displays a measured value in numerical readout instead of a pointer indicating the value on a scale. An example here is employing a central dial which is made to point at a particular value range to be tested. DC volts, DC amps, AC volts, and AC amps. In the case of resistance, infinity here is registered as OL. OL stands for overload. The meter senses no measurement which is within its set range. It interprets this as overloading until it senses a load which it can measure. The process of measuring a known resistance is the same as described earlier. Here's another type of digital meter which employs toggle switches at the side for setting the desired scales and values. These must be pushed in to set the meter to read a desired scale. The number 1 in the display window represents the first significant number without an actual value being measured. The method of reading a measured value is the same as seen previously. When you finish using a test meter, it is advisable to cancel your settings and switch off the meter. An insulation resistance tester is used to monitor the condition of the electrical circuitry on board ship, as well as for fault tracing. On this particular model, there is a battery test as well as ohm, kilo ohm, and megohm scales. The meter is tested on all its scales before use by connecting the probes together when the meter shows no resistance or closed circuit on all its scales. Then the probes are separated and the meter shows open circuit or a resistance value of infinity. Remember not to touch the probes when activating the meter. They will have 500 volts on the megohm scale, in some cases higher. Finally, a line tester, set to test for the presence of 220 volt supply. First, the voltage on the test panel is set. Then the line tester, or a multimeter for that matter, is tested for correct function. These test instruments are all used for monitoring the condition of electrical installations or for assisting with fault diagnosis or fault finding. The electrical plant and circuitry installed on board ship are subject to wear, tear, and aging. They operate in an environment in which there are great changes of temperature, humidity, salt level in the moisture of the atmosphere, and vibration. They do need constant condition monitoring and maintenance. Preventive maintenance, based on time schedule, was a frequent method of avoiding costly breakdowns. Some chief engineers and electrical superintendents favour preventive maintenance based on insulation resistance trends and vibration monitoring to guide their maintenance planning. Regular vibration monitoring is carried out by one or another method, seen here being done on a small pump motor. The results of the measurements are carefully recorded for future comparison. This should ensure that developing problems are dealt with before they become serious and costly to remedy. Maintenance should always be carried out on the basis of a prepared job sheet, and in the case of high voltage systems, on an approved and recognized permit to work system, which should be rigidly adhered to. Well, this concludes the subject of Programme 1. In it, we described a typical ship's electrical system in broad outlines and some of the most frequently used graphic symbols. We discussed safety and emergency rescue procedure and continued with setting up some of the most frequently used test instruments. Finally, we talked about the modern thinking on preventive maintenance. This program was designed to guide you through the initial stages of getting to know a ship's electrical system and point the way towards further information. A more comprehensive description of a ship's electrical system will be found in these books, forming part of this series. Fault analysis and recommended remedial procedures are provided in computer programs, also forming part of this series. For more details regarding the distribution system, alternators, batteries, motors, starters, lighting and ancillary electrical equipment, please refer to other programs in the series listed here.